Northeast Greenland is a very interesting area for my research. It is a crucial area to study, and also it is, in a way, it is uncharted land. I mean, the place where we were working on at Station North, we don't have a sound bathymetry of the area, so we don't know, for instance, the depth of the fjords. They are not mapped yet. My name is Sofia Ribeiro, and I'm a researcher at the Geological Survey of Denmark and Greenland. I work with climate and environmental history. Over the last decades, and since the Industrial Revolution, we are seeing changes that are extremely rapid, that are not fitting with what we know of natural climate variability, and that are influenced by human activities. We can see that there's been an incredibly fast loss of Arctic sea ice over the past 30 years. It's not fitting with what the models we have of natural climate variability can show. So we need to go further back. And the way to go further back in time, when we don't have reliable, continuous records of data showing us sea ice changes, is to use these very important archives, like sediment archives, like tree rings. Our mission at Station North was to collect sediment cores, so sediment archives from the fjords up there. We had to drill through the ice, through the sea ice, and had first to remove all the snow that was on top of the ice at -20, and knowing we had a tight schedule. So typically we would go in the field every second day and work for 10-12 hours out there. We could not go on field work without having a rifle, because it is an area where polar bears are often seen, especially if we were going out in the field. And we had radios with us all the time, so we had to communicate to the station where we were, how long were we staying, and definitely if we saw a polar bear, we were told to notify the station right away. And we had these symbols, you know, danger, polar bear, everywhere, inside and outside the house. When we come back from the field with a lot of sediment cores, we will go through a long process of screening the samples to select which ones are good, which ones are giving us a good resolution and undisturbed record of what we want to look at. And then we will process the samples in order to extract from them the information that we need. And all of this will give us a time series of change that we then compile, and that will then help us create a picture of what changed over time in this area. When we look at sediment cores, we will process the samples in a way that will, of course, affect our results. And among other things, we use acids to treat the sediments in order to obtain the microfossil fraction that we look at. But if you don't do that, if you look at the sediments just as they come out of the ocean, you'll actually realize that there's a lot of living things in the sediment. There are species that are also autotrophic, so they are doing photosynthesis just like plants, and there are species that are behaving like animals. Some years back, we found out that dinoflagellate cysts could actually remain alive in the sediments for 100 years. So in a way, we felt that we were turning geology into biology. We were starting with something that could be classified as a microfossil, and then ending up with something alive today. And someone was telling me it is like a Sleeping Beauty story, because Sleeping Beauty also sleeps for 100 years. They are perhaps not as beautiful, but they are definitely very, very interesting. We can use also the living archive in sediment cores to tell us something about how the environment changed. And what we're doing now is to looking at the genetics of how these organisms have been changing in time in relation with environmental disturbances. So we use the past. In climate research, we often say that the past is the key to the future. We use the past to inform how the processes and how the natural variability has occurred, and this will be the basis for making future predictions.